This is just a powers chart, what it has on it. I'm going to highlight one number here. This means 4 to the power 3. 4 to the power of 3, or 4 to the exponent of 3, is equal to 64. Now, these are all the numbers that you are expected to be able to use without your calculator. And, well, a little bit of them, like some of these, I sometimes go one beyond what I think you'd have to do without your calculator. So as you get higher, like something like 7 cubed is 343. If you don't know that without your calculator, you're probably going to be fine. But what we're going to do is we're going to use these powers charts to solve exponential equations. An exponential equation is just where the power has the variable. So if you were trying to solve 3 to the x equals 81, you could go back to your powers chart and say, is 81 in our powers chart for a base of 3? Yes. What would the exponent then be? The exponent would be 4, because 3 to the power of 4 is 81. So what we're going to do in solving these kind of questions is we're going to look at the numbers that are given, and we're going to say, are those numbers in the same column in our powers chart? For example, in the first one, we have 4 to the x and 1 over 256. Is 256 in the powers chart for 4? Yes. So what we can do is we can take 256 and rewrite it. It is 4 to the power of 4. Our goal is to take our equation and write everything with the same base. Then use our exponent laws to not only have the same base, but to have the same base on both sides. Right now on the right side, my base is on the bottom. How would I move the right-hand side so it's 4 to the power of something and it's not on the bottom? You use my negative exponent rule, I get 4 to the negative 4. Once you get both sides with the bases the same, you can tell what x is. Okay? So if the bases are the same, 4 to the x equals 4 to the negative 4, then the exponents have to be the same. So we're able to say that x, just by observation, x is equal to negative 4. Now in B, we've got 27 and 9. 27 is not part of the powers chart for 9. If you look at your powers chart at 9, the first number is 81, 9 squared. But do 27 and 9 ever appear in the same column of another base? Yes. They both appear in the base of 3. So what we're going to do is instead of 27, we're going to write 3 cubed. So we have 3 cubed to the x equals, and instead of 9, we're going to write 3 squared. So what we've done is we've started the process of getting the bases the same. Now we do have to do some work, just like the last one, we have to do some work with our exponent. What is the exponent rule when you have an exponent to an exponent? You multiply. So here I'm going to get 3 to the 3x, and here I'm going to get 3 to the 4x minus 2. Once again, now that my bases are the same, 3 to the 3x equals 3 to the 4x minus 2. I even sometimes write, so 3x is equal to 4x minus 2. Get your x's to one side, move your 2 over, and we find out that x has to equal 2. Questions we can do, I'm going to get you to try some of these. 3, 4, 5, and 6. Thank you. You can just put it under there.